Hello everybody, this is our second session, exercise number. We will continue this exercise number 2.1. Last time we discussed till this question number 3. Now we're going to start with this question number 4. Determine whether the values given against each of the quadratic equation are roots of the equation. So this is our first question where x square plus 4x minus 5 is 0. And we have two values of x, one is 1, the other one is minus 1. So we need to verify which of them is a root of the given equation and which of them is not a root of the given equation. So I'll take this question on my sheet. Here we have question, this is x square plus 4x minus 5 equals to 0. So this is given equation. What I'll do, I'll take my left hand side. This quadratic equation has two sides. This is left hand side of the equation and this is right hand side of the equation. Equation says both the sides, that is left hand and right hand, are equal. So whichever value of x will satisfy this equation will be considered as a root of this equation. Like here we have two numbers 1 and minus 1. So I'll substitute 1 and minus 1 on the place of x. So first I'll take my left hand side. My left hand side is x square plus 4x minus 5. This is left hand side of the equation. Now we will substitute x equals to 1. So when you substitute x equals to 1, here we have x square. So we can take 1 square plus 4 into x, that is 1, minus 5. 1 square will remain 1 plus 4 ones are 4 minus 5. So this way, this plus 1 and plus 4 will give me plus 5 minus 5. So this will become 0. So as you can see, left hand side, in left hand side, after substituting 1 on the place of x, so this is 1, we are substituting on the place of x at left hand side. So that makes your left hand side as equal as your right hand side, because the right hand side is already 0 and left hand side also becomes 0. So in that case, we can say that left hand side is equal with right hand side of the equation. Both are 0. So therefore, when it becomes equal, that is left hand side and right hand side, which means 1 is satisfying this equation. So here we can say 1 is root of the given equation. Similarly, now I'm going to substitute minus 1 in order to verify whether minus 1 is root of the given equation or not. So again, I need to take my left hand side of the equation, which is x square plus 4x minus 5. This time I'll substitute my second number, that is minus 1. I'm going to substitute on the place of x. So here I'll take minus 1 whole square plus 4 into minus 1 minus 5. So on substituting minus 1 square, that is 1. This plus and minus will give you minus 4 ones are 4, and this is minus 5. So in that way, 1 will remain as 1. Negative 4, negative 5 will become minus 9. So when you subtract 1 from 9, you will get minus 8. So on substituting minus 1 in the given equation on the left hand side of the given equation, it gives me 8. On the other hand, the right hand side of the equation is 0. So it is clearly seen that on substituting minus 1 in the given equation, left hand side doesn't becomes equal with the right hand side. So here you can say minus 1 is not satisfying the given equation because left hand side and right hand sides are not equal. So therefore, you can conclude that minus 1 is not a root of the given equation. Hope it is clear to everybody. Now we will move on another question. Again, now I am going to this question number 5 of exercise number 2.1. What is what does this equation says? Find k if x is 3 is the root of the equation kx square minus 10x plus 3 equals to 0. So this is the given question. I'll take this question on my sheet. So here we have a question. This is question number 5. Find k if x equals to 3 is a root. So it is clearly mentioned that x equals to 3 is the root of the given equation. The equation is kx square minus 10x. So this is kx square. Remember that. Kx square minus 10x plus 3 equals to 0. This is my given equation. So if x equals to 3 is one of the root of this equation, so definitely this 3 will satisfy the given equation. So in that case, here we can say since x3 is the root of the equation, so we can say kx square that is k into 3 square. We are substituting actually 3 on the place of x. So minus 10 into x that is 3 plus 3 equals to 0. Now 3 square that is 9k minus 10 3s are 30 and this plus 3 equals to 0. I am keeping 9k on its place. This negative 30 and plus 3 minus plus minus, we will take sign of greater number. 30 minus 3 that is 27 is 0. So keep k on its place. This negative 27 will become plus 27 when I'll bring it to the right hand side, and this 9 is multiplying with k on the left hand side. So when I'll bring it to the right hand side, it will divide. So I'll write it in the denominator. So k is 3. This is value of the k. So this way we can find out k. Now we're going to solve practice set number 2.2, where the first question is solve the following quadratic equation by factorization method. First equation, x square minus 15x plus 54. I already taken this equation on my sheet. We will just solve this equation by using factorization method. So in this chapter, we shall discuss the factorization method to solve quadratic equation. We will discuss formula method to solve quadratic equation. As well, we will discuss completing square method to solve quadratic equation. So in this chapter, you will learn three methods to solve any quadratic equation. Now, first method which we are going to discuss here is factorization method. This is special method which require certain some special qualities or some special conditions are being required in the given quadratic equation to solve those equations by factorization method. All quadratic equation cannot be solved by factorization method. Only those equations we can solve which follow certain rules. For example, as we know, this is in quadratic equation we used to consider this is first term, this one second term, and this one third term. I'll take coefficient of first term and coefficient of third term. So I'll find out product of coefficient of first term and coefficient of third term. So in my equation, the first term is x square, so there is no coefficient. So I can consider 1 over there. So this x square has coefficient as 1. So this is coefficient of first term, that is 1. Now I'll multiply coefficient of third term. So coefficient of third term is 54. So 1 into 54 will become 54. So this is product of coefficient of first and third term, that is 54. Now we need to find out two linear factors for 54 in such a way that when you multiply them, those two factors, they should be 54, and when you add those two factors, they should be same as coefficient of second term. So in our equation, coefficient of second term is minus 15. So here I'll take minus 15. So we need two linear factors whose product is 54. So I can take 9 6 54. Since I need positive 54, so and negative 15, so what I can do, I can take negative 9 and negative 6. So when you multiply two negative numbers, the product would be positive, right? And when you add two negative numbers, their sum will be negative 15. So it is clear that minus 9 and minus 6 are required linear factors for this equation. I'll substitute minus 9 and minus 6 on the place of middle term along with the variable given in our equation. So therefore, this can be written as x square, that is your first term. Then I will not take this 15x. Instead of this minus 15x, that is middle term, I'll substitute minus 9x and minus 6x. So here we can take minus 9x and minus 6x. And last term will remain same, that is plus 54. After this, previously, our original question had three terms. But after replacing middle term with these two linear factors, we have four terms. So these four terms can be grouped as first two terms together and last two terms can be grouped together. In first two terms, we can take out something common. So you need to observe what is common in first two terms. So here we have x square minus 9x. Among them, x can be taken as common factor. So this x square has two factors of x. If you take out one x out, one x will remain minus 9x. So we have already taken x as a common factor. So here you will have only 9. Same way, in another pair, we have 6x minus 6x plus 54. So I can take out 6 as a common factor because this 54 has 6 into 9, correct? This 54 has two factors as 6 and 9. So each of these two factors can contribute 6. So I'll take 6 as a common factor. So here you will have x. Since I am taking minus as a common factor, minus 6, so this plus sign will change to minus. So here I'll take minus. Since it was 54, out of 54, 6 is already taken out as a common factor, so you have only 9. So here you can take 9 equals to 0. Since these two factors are same, so you can write them once, that is x minus 9 is one factor, and this x and minus 6 will give you another set of factors. So here I can take x minus 6 equals to 0. As you can see, we have x minus 9, x minus 6, both are multiplying together, which is equals to 0. So in that case, you can say x minus 9 equals to 0, or x minus 6 equals to 0. If x minus 9 is equals to 0, so keeping x on its place, this negative 9 will become positive 9, or this negative x will become positive x. So x is 9 or x equals to 6. These are 6 and 9 are the roots of the given equation. So you can write your final answer that 9 and 6 are the roots of the given equation. So this is our solution. Now let's move on next question. Here we can take one more example. Like I can take this one, sixth question. So I am taking this question number 6. We need a new sheet to solve this question. Again, we need to arrange this equation, or we can write it in we can write this equation in proper way. I'm going to solve this question number 6. So here we have 6x square minus x equals to 1. This is actually our original question. Now I'll delete this question. Okay, so this is our question. We can just cross check 6x minus 2 by x equals to 1. Okay, there is some distortion in our question. 2 by x. So 6x minus 2 by x. So this question is something like this. 6 by 6x minus 2 by x equals to 1. So our question is something like this. We're going to solve this question. First, we need to simplify this equation. Here we have 6x minus 2 by x equals to 1. So what can I do in order to bring this equation in proper standard form? We can multiply the given equation by x. So multiplying the given equation by x. So when you multiply this equation by x, so 6x into x will give you 6x square minus, on multiplying x with this term, that is 2 by x, you will get only minus 2. 1 into x will give you 1x. So this equation will look like this: 6x square minus x minus 2 is 0. Now I'll take coefficient of first term and third term, and their product is minus 12. So I need two linear factors whose sum should be minus 1, because coefficient of middle term is minus 1. So here we need to find out two such linear factors whose product should be minus 12 and their sum should be minus 1. So in that case we can take negative 4 and positive 3, that is minus 4 and plus 3. So a negative and positive number, uh, when you multiply these two factors, you will get minus 12. On adding, they will give you minus 1. So I can substitute this minus 4 and 3 on the place of middle term. So this way we can write it as 6x square minus 4x plus 3x minus 2 is 0. We can group them, first two together and last two together. Here 2x can be taken as common factor. So 3 2s are 6. So you will get 3x square 3x minus 2. Here we can take out plus 1 as common, because there is nothing is common in these two terms. So when you don't found any common term or factor in the given terms, so you can simply take out 1 as a common factor from both the terms. So here I am taking 1 as a common factor, so these numbers will remain same, that is 3x minus 2 is equals to 0. So 3x minus 2, 3x minus 2 is same, so you can write them once. 3x minus 2 is one factor, another factor will become x plus 2x plus 1 is equals to 0. So here you can say 3x minus 2 is equals to 0, or 2x plus 1 is equals to 0. So therefore, keeping x on its place, this negative 2 will become positive when I'll bring it to the other side, and this 3 is multiplying with this x. So on bringing it to the right hand side, it will divide. So x equals to 2 by 3, or here x equals to minus 1 by 2. So your answer is 2 by 3 and minus 1 by 2 are the roots of the given equation. So this is your solution for this question number 6 from exercise number 2.2. Okay, we're going to solve this question number 8 from same exercise number 2.2. Question number 8. This is quite different from other questions. Here we have 3x square minus 2 root 6x plus 2 is 0. This is our question. We need to solve this question by splitting middle term. Now what we can do in order to solve this question, same way, first you need to observe whether the given equation is in proper standard form or not. Ax square plus bx plus c equals to 0. So as you can see, this equation is in proper standard form. So I'll take coefficient of first term. So here coefficient is 3. So here I'll take 3 into. I'll multiply coefficient of third term, which is 2. So 3 2s are 6. Now we need to find out two linear factors of this 6 whose sum should be minus 2 root 6, that is coefficient of middle term. So coefficient of middle term is minus 2 root 6. So here what I can do, I can simply take my minus root 6 and minus root 6. These two can be minus root 6 minus root 6. So when you multiply, we know we have already studied this rule that root a into root a is equals to a. So same way root 6 will give you 6. So on multiplying these two, you will get positive root 6, positive 6, and when you add them, so this is 1 root 6 and this is 1 root 6. So minus minus minus. So on adding 2 negative root 6, you will get minus 2 root 6. So I'm going to substitute my linear factors on the place of middle term. So my linear factors are negative root 6, negative root 6. So I'll substitute on the place of this minus 2 root 6. So this way it will look like this: 3x square minus root 6x, again minus root 6x, and third term will remain same, plus 2 equals to 0. We can group them as first two together and last two together. What is common in them? In first pair, as you can see, first term has coefficient as 3. So this 3 has actually root 3 into root 3, and this root 6 is also root 3 and root 2, because root 3 and root 2 together will give you root 6, root 3 into root 2. So 3 2s are root 6, and root 3 will become 3. So this 3x square and root 6 as root 3 as common factor. This 1 root 3 can be taken as common factor from both 3x square minus root 6. So here we can take out root 3x as common factor. So when you take root 3 from this 3, you will left with root 3. Root 3, it has two factors of x, that is x square. One went out, so you will have one more x with this root 3. Now this root 6 had root 3 and root 2. So root 3 we have already taken out. So what is left? Minus root 2 is remaining. Same way, similarly, here we can take out this root 6 has root 3 and root 2. This root 6 has root 3 and root 2, and this 2 has root 2 and root 2. So I can take out root 2 as a common factor. So this root 6 will have root 3 x plus, I am taking minus sign, so this plus will change to minus, root 2 is remaining on the last term, is equals to 0. So these two are same. So here you can say root 3 x minus root 2 is one factor, and other factor is root 3x minus root 2 is 0. So we can say root 3x minus root 2 is equals to 0, or root 3x minus root 2 is equals to 0. Keeping x on its place, this negative root 2 will become positive root 2, that is root 2 upon root 3, or x equals to root 2 upon root 3. So here your final answer is 2 root 2 by root 3. Since both the roots are same, so you can write them once. Root 2 by root 3 is the root of the given equation.